Hey, Algebra 1. Let's go over some of the homework yesterday. Particularly, this is number 25 I wanted to go over. And I changed them to x's from s's. So it equals 0. So what we're going to do is still do the same thing. And we're going to ignore this as it equals 0 and just still do our ABCs with a capital C. So ABCC. 4, 11, negative 3. And when I bring that over, that becomes negative 12. So that's a negative 12. So I'm looking for things that multiply to negative 12 that adds to positive 11. Well, positive 12 and negative 1, which is like our first combo, does add up to 11. So that's really good for us. So then we get x plus 12 and x minus 1. Then we're going to do our divide. We can't forget to divide the original a. So this reduces to x plus 3, so we're happy with that. This over here, you could move the 4 in front. So that's 4x minus 1. This cannot simplify, so we're forced to move the 4 in the front. This is where the equals 0 pops his ugly head. Not really ugly, just simply, his head. Now we're going to set each one separate as equals 0. So x plus 3 equals 0, and 4x minus 1 equals 0. So minus 3, x equals negative 3, and 4x minus 1 equals 0, plus 1, 4x equals 1, divided by 4, x equals 1/4. And I just want to point out something. Notice, I mentioned this before in the 8.5, but this is positive 3. The answer ends up being negative 3. That's always true. It's always going to flip signs. Over here, look at what it was before, negative 1/4, and it became positive 1/4. So you could use this to either check or even get right to the answer. All right. So today we're going to talk about one last thing in 8.6, which is what happens if it doesn't equal 0. What happens when this equation does equal 0? And then we're going to do some special cases in 8.7. Okay, so this is number 26 on the page of the homework. 7a squared plus 2a equals 5. All right, so my big issue is 1, this doesn't look like ABC, and 2 is not equal to 0. So what I'm going to do is subtract 5 on both sides. So now I have 7a squared plus 2a minus 5 equals 0. Now, what does that cause? Well, now it looks like it equals 0, and now it looks like an ABC. So if you're making like a step list, I don't know what to call this, because I think we already have a step 0 or step 0.5. So call this like step -1. Step -1, make it equal 0 by subtracting whatever. So I have to subtract 5 to get this to 0. And then the negative 5 popped up here because it can't mix any terms. So before you even start, you got to make sure it equals 0 to do the problem at all. All right, so I'll still continue the problem as normal. A, B, C, and then a capital C. So we got 7, 2, negative 5, and that's going to be negative 35. 7 times negative 5 is negative 35. So I'm going to look at what multiplies to negative 35, and that adds to 2a, or just 2, I should say. Well, look at this. 7 and 5 I know multiply to each other, so 7 and negative 5, hey, that does equal 2. So 7 and negative 5 is my two winners. This is A. A plus 7, A minus 5. Then we're going to divide by our original A, which is 7 in this case. So divided by 7, divided by 7. This simplifies to A plus 1. This does not simplify. So this, you can move the 7 in front. 7A minus 5. Now both of these equal 0. I could split and solve, but I'm going to use the trick that I mentioned last question. I know this is just going to be the opposite of whatever's here. So instead of +1, it's a equals -1. And over here, I know it's going to be the opposite of this thing. So it's going to be a equals +5/7. And if you want to check the work, you can and do it out. But I'm just showing you that shortcut is helpful to save some time on these longer questions. Okay, so that's it for 8.6. I'm probably going to put 2 more problems, most likely 27 and 28 of this type. And let's get to special cases. Okay, so we're going to start 8.7, factor special products. So first off, let's talk about what is a special product. This is the same things that I was talking about, I believe, in 8.3. So let's say if we have, let's do 2x minus 5 and 2x plus 5. And we FOILed it out. So that's 4x squared. That's plus 10x. That's minus 10x. And that's negative 25. These cancel out because plus 10 and minus 10, these cancel out. So all I'm left with is 4x squared minus 25. If you remember, this was considered a special case. And the special case worked like this. ax plus b, ax minus b will end up equaling a squared, x squared, minus b squared. And that was the special case. Now the question is, why is that important? Well, in factoring's the opposite. So we're going to go from here and get back into these two parentheses. Because what we did here is distribution, the opposite is factoring. We're going to go from here to here. So let's do an example problem, and I'll keep the equation up here. Let's do 9x squared minus 4. All right, so 9x squared minus 4. Now, there's like 2 tests that you have to pass. There's 2 tests you have to pass to make sure this is a special case. Test 1, are both terms perfect squares? So test 1, is both terms perfect squared? So we got 9x squared minus 4. 9 is a perfect squared, x squared is a perfect square, and 4 is a perfect squared. So that passes the first pass. The second test, factor out what is in common. So when I say factor out what is in common, that is the same thing as what we did in 8.5. So do we have any greatest common factors between them? No. Do we have any variables in between them? No. So step 2 is done. Okay, or test 2, I guess. So now they pass both tests. We can now do the special polynomial. So if we know a squared equals 9, what would a just be? Well, it would just be the square root of 9, which is 3. And if we know b squared is 4, what would b just be? Well, the square root of 4 is 2. So you don't have to draw this part every time you do the problem, but I'm just pointing out that since we look at this, which is 9x squared, we know 9 is the square of 3 and x squared is the square of x. And then 4 is going to be the square of 2, so I write 2. So basically, you got to make sure you know your basic square roots in order to do this. So 3x plus 2, 3x minus 2, you're done. There's nothing more you can do. Because these pass the test, you know for a fact there's nothing more you can do. Let's do just one more. Let's just do x squared minus 16. Oh, I should say also, I guess maybe I put this in the test also. It should be a minus sign in between. It doesn't work if there's a plus sign. All right, so you got x squared minus 16. Now, is the first one a perfect squared? Yes. Is the second one a perfect squared? 4 times 4 gives you 16. Yes. Can you take anything out right now? No, I cannot. So, if that's true, then this, for a fact, is a perfect square binomial. So now we could just simply factor it. The square root of x squared is just x. And the square root of 16 is just 4. So we got x plus 4, x minus 4. We are done. That's how quickly you can do these problems, okay? So that's the first type of special case. We're going to go right into the second type. Okay, so before we start factoring the special product, let's talk about what was the special product. If you remember, x plus 3 squared, you were forced to rewrite it as x plus 3, x plus 3. But this had a special rule. So a plus b squared should have become, should have left a little bit of space here, will become a, it should be ax, I guess. So a squared x squared plus 2 times a times b times x. So 2 times a times b times x plus b squared. So over here, x is a, so it's just 1x. So that's 1 squared x squared. So then we're going to do 1 times 3 times x times 2. So that ends up being 6. Or I guess 2 times 1 times 3 times x. So that's 6x. And then b squared is 3 times 3, which is 9. So this is the answer for that one on top. And this is the formula. So what we're doing today is that what we're going to do is try to get from here to here. Now, I do want to point this out. You can still technically use the FOIL rules that we learned from 8.6 and 8.7 to do this. So the tests for here are slightly different, but they still work. So let's make one up. 4x squared plus, this is going to be a 25. So, and this is going to be 20x, okay? So 4x squared plus 20x plus 5. This is our example. So 4x squared plus 20x plus 25. Here's the tests. So the tests when we have 3 terms, okay? And you only run these tests when you notice this one and this one's a perfect square. So test 1 is the first and last term perfect squares? Yeah, they are. 4 is a perfect squared, x is a perfect squared, x squared I should say is a perfect squared, and 25 is a perfect squared. 2, so those are perfect squares. 2 is the middle term. 2 times a times b times x. So what do I mean by that? Well, if I think 4, a squared equals 4, then I think a should equal 2, right? Same thing here. If I thought b squared, the perfect square is 25, then b equals 5. So now we're going to check if this one right here, follows 2 times a times b times x. So 2 times what a I just said it was. So that's 2. Times b, what I just said it was, which is 5, times x. So 2 times 2 times 5 times x. That ends up being 2 times 2 is 4, 4 times 5 is 20, 20x. Hey, those match. So those match. Since it passed the 2 tests, now I could write it as ax plus b squared. So what was a? 2. What is x? Well, that's x, so I should have said that. And what's b? Well, that's 5. So 2x plus 5 squared is your answer. Okay. Today I won't be able to do a Zoom during class time. So if we have Zoom, it'll be the next time we have class, which is either Monday or Tuesday, all right? So I'm sorry if you have questions and you need a Zoom to help, but I'm available on Remind / the Google Classroom private messages. All right, good luck, guys.